Hello everyone, we are assigned to make a PC-based logic analyzer. As we know, a logic analyzer is used to convert captured data into timing diagrams, just like an oscilloscope. So the difference is logic analyzer can show digital data, it can show more than 2 channels at a time. So our project will deal with 16 channels. So here are the guys, they are working for the project.
Hi, I'm Zobaer. We two are surfing on the internet to find some circuits for USB interfacing.
We are trying very hard, but we are not yet done.
Hi, this is Jawadul.
And this is Samantha. We are working on the circuit. It's still finished.
We are about to it.
In this project, we are asked to make the circuit on the PCB, but now we are working on BUET.
So we have to test it in computer to make sure that the device is working properly, which is our desired operation.
Now the circuit is finished and ready.
Now we can go for the PCB layout.
This is our PCB. It's the top layer and it's the bottom one.
You can see the microcontroller and other necessary equipments for the logic analyzer. Here is the USB interfacing circuit. The USB cables are connected in these pins. You can see a 12 MHz crystal since we are operating this circuit at 12 MHz. These are the input for 16 channels. These are for channel 0 to 7 and these for channel 8 to 15. We use some other switches for special features. This is used for pause, stop, inversion and single channel mode.
In case of designing any circuit with switches, an important concern is pull-up or pull-down resistance. Where there is a switch, there should be a resistance with it. In our circuit, we haven't used any such resistance with these switches. Rather, we have activated the internal pull-up resistance of this microcontroller, and by doing this, we have managed to make our circuit simpler. When the switches are unpressed, the connected pins are high, and when the switches are pressed, they become low.
We are familiar about the term contact bounce. So as we know, every switch has a contact bounce effect. So using capacitor, we can solve this problem, but we have tried to solve this problem in a sophisticated way. So by code, we will prevent contact bounce. So using interrupt and timer counter of microcontroller, we have solved this problem. So it just eased the circuit complexity and it looks very wonderful. Here you can see here, there is no capacitor besides any switches. In every switches there is no capacitor. You can see here very clearly. So now I will show you the switch transition. If I press this switch 1 time, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we can see here the switch transition is occurred very smoothly. So and it is not so fast.
Now I will show the codes for our project. We have actually 3 codes. This is the microcontroller side code. This code just sends the data from the microcontroller to PC. We compile this code using Visual Studio. And this is our PC side code which receives the data from the circuit. We compile this code using Visual Studio. And then for plotting we used MATLAB. And this is our MATLAB code which plots the received data from the circuit.
Okay, now the demonstration part. We will show our logic analyzer is what. Here we have made an input circuit where some automatic inputs are generated by microcontroller. This is in fact a counter, and here some buttons are placed by which we can give inputs by pressing these buttons. Now let me start the program for showing the course. You see, here is a plot of all 16 channels. We can give inputs from this circuit. So let's first give the power to this circuit. And you can see the counter, the output of the counter. See, it's a counter, and its distribution bit is of 250 Hz. So our logic analyzer is capable of showing 250 Hz inputs. And here are some buttons for manual inputs. Let me give some inputs there, and the outputs will be shown on channel 0. You can see high, low. I'm giving my hand and this one. And also I'm giving it channel 2, like high, low, that's how we can show the logic states of various points of the circuit.
Now I am showing you our first feature, pause. This button is used for pause. If I push this button, the channel will be paused. Look, the channels are paused. If I give some input to the features, it will not take any input. If I push it again, the channels will be resumed. See, the channels are resumed. This is how the pause option is worked.
I'm going to show you the single channel mode of our project. This is one of the special features. The transition to single channel is done by this switch, and the channel memory select is done by pressing this switch. For example, I'm going to press channel 8. 8 is selected. Now if I press this switch, only one channel will be visible in the enlarged form. You can see, previously there were 16 channels together, now there is only one channel, channel 8. Channel 10 is pressed, so you can see channel 10 in the enlarged form. If I press the switch again, we will get back 16 channels together. That is, I am moving out from single channel.
Now I will show you another feature of our project, which is inversion. By using an invert button, we can invert any one channel or all of 16 channels. Here I am showing this. Well, to invert a single channel, we have to select the channel by using this channel selection button. So we can invert channel 1, here 1 is selected, and then we are pressing this invert button, and you see here an inversion indicator LED is glowing, and you can see in the plot that channel 1 has been inverted. And here we can give some input here from here, and you can see when I press, and then it is showing low, otherwise it is high. And if I press this invert button again, then you can see channel 1 becomes normal. And now in order to invert all 16 channels, we have to select blank here. Blank is selected, and then I am pressing this invert button, and you see the LED is glowing, and all channels has become inverted because everywhere there is high. And again I am pressing this invert button to bring all these channels in normal state. And in this way we can invert our channels.
Now I will show you one of our additional features, and that is stop switches. If we push the stop switches, it will stop receiving data from circuit. So here is the switches. You can see here are the switches. So if I press the switch here, then they will exit the code and it will stop the program. So you can see I just run the program. If I push this stop switches, and it will stop receiving data. Now push it. Yeah, there it shows the message that the device is stopped, and now the network program will start. So the clear understands after pushing switches, the network stop, network exit from the board, and you should this message. This is say I have